on that. Do you want me to go through the entire system again, just for the recording sake?
Yeah, just do it real quick because I know the powers that be are going to want to see the rocket. So
okay. So starting from the top, guess one thing to go. Nose cone tip, aluminum 6061. That then permanently gets fixed to the fiberglass nose cone. The nose cone is an S-grad fiberglass laid on a positive mold and then vacuum bag. This is made by fiberglass sleeves, 5 layers, about 80 thou thick. That makes to a coupler. This coupler will be permanently attached about 3.5 inches on the fiberglass, the nose cone side, permanently affixed, and then just over 1 body caliper on the forward tube side. There will be nose cone avionics secured to this ring, slid in from the bottom and secured with M3s. This ring will be permanently fixed in and sandwiched between the coupler and the slow taper of the nose cone. Moving on to the main body tube, this is a commercial filament wound carbon fiber tube. It's about 70 thou thick. So that's the forward brake for the main, and then that's the aft brake. It's dual split, dual deploy. At the drogue brake, same thing with these couplers. These couplers are similar thickness, they're about 60 thou thick instead. This is the sliding joint, so just over 1 body caliper on either side. Moving on to the aft, just again, I'll reiterate the slight issue with the manufacturer. This tube is out of spec. We're getting a new one shipped to us. Centering tube for the 6-grain XL that we're flying. And then moving on to the fin can. Fin can is coupled to the aft body tube with a same coupler. The way we laid it up is we had a Mylar, essentially release film that allows, when we laid it up, we use a slightly thicker, like sacrificial coupler, so it allows a really tight fit on that. So that's 1 caliper onto the body side and about 3-ish inches. We still need to trim this onto the fin can side. Fin can side is a tip-to-tip layout, 4 plies on the tip-to-tip and 4 plies on the structural part with 8 in the overlapping area. This is about 80 thou thick. We're going to sand this and then cut on a bandsaw to get a smooth thing here. We're still taking our time, so we're going to mark the fins and chop that off. The thrust load is carried by the aft system. So you see the outer thrust ring, and hidden is the inner one that is sandwiched between the cardboard tube and the carbon fiber. It is screwed in with these M3s and sandwiches our layup. You can see a thin layer of carbon fiber. So the core itself on the inside of the layup doesn't carry any load. It's all through the fiber. Aft closure of the motor sits on the ring and then is secured with a motor retention ring. This is last year's design, but we have the stock. We just need to make the one this year. And then going back to the bulkheads, we had a start. So 2 bulkheads for the 2 brakes, forward bulkhead and aft bulkhead. They're designed to be all installed through the drogue brake, as in the forward bulkhead will clear the aft ring. We still need to do some post-processing to make sure this is a clearance fit, but these rings will be permanently affixed in the rocket. This passes through and then installs onto the forward one, and then the back installs like so. A gasket material will be sandwiched in between them, I think. Yeah, it's a rubber gasket material sandwich that. And then we're using Raptors for deployment. That is an overview of the airframe. Shall we get down into the systems?
Yeah.
Okay.
Just one quick question. Can you show me where you're? How are you planning to put your rail buttons in? And can you show me approximately where they are on your airframe?
Yeah. So rail buttons, we're doing a similar system as we did last year. We are going to machine little aluminum blocks, so they have the contour of the inner diameter of the body tube with the thread for the buttons. The aft one, we're going to place it just in front of the coupler mating section, so about, I would say, 5.8 inches from the brake. I think that was what it is on the CAD model. So around right here. The forward one, I believe we are putting it just aft of the forward bulkhead, so around here.
Okay. Okay, and how are you going to fasten that to the are you just going to go through with some kind of something on into some kind of a backing
Yes.
backing thing, or you're going to
Yeah.
tie it into stringers or your bulkheads or what?
So it's just a small aluminum block that we're going to put on the bottom of the bulkhead. It's going to be independent to the bulkhead, so we can install later. It's the same system we used last year. They're essentially just little aluminum wedges where the that wedge, that round part matches the inner diameter of the thing, so we can put a through hole through the carbon fiber, and then the actual part is threaded. So we just take. We don't do anything fancy. We just use standard 15-15 lugs and through thread. We're not going to use the screws they provide with the kit because they're too short. They only bite in, I think, 3 or 4 rotations, and we've had a bad experience with that at a Canadian competition. So we're going to get our own screws, and also Phillips head. We're going to get one with hex, just so we can use the same keys at the pad and at the assembly area, just for convenience.
Yeah, good plan. Yeah. Okay.
Yep. So I guess move. Yeah. Sorry. Okay. I guess we'll go through the systems from a chronological order. So in terms of starting from, like, as in motor first, and then we'll talk about deployment, and then so on and so forth, payload. So motor, we're flying a CTI 6-grain XL casing. The reload is an N5800. We tried to get another O3400 just because the thrust curve is a lot more gentle, and it's not 3.5 seconds a rocket up at 8 kilonewtons. So it's an N5800. I mentioned earlier, we're going to have sort of rings to center this with a cardboard tube that is, I think, sold by Lock Precision, that centers this whole mess in the aft. And then you want to talk about deployment, Callie?
So for the drogue deployment, we have our brake here. So we have, I want to say, a total of 35 feet of 1-inch tubular nylon shock cord with I think it's rated for 18 kilonewtons. Holding up the drogue, and I think we've also redesigned our drogue this year, which Nico can talk about more. But as the fancy and more interesting deployment stuff happens with Maine, because we have deployable payloads. So I'll get to that after we go over the drogue.
Okay, and your hardware for attaching things, are you using quick links, or
we have
for attaching the shock cord to your bulkheads and so forth?
Yeah, we're so eye bolts on for both bulkheads, and then I think there'll be 2 swivel links, one at the base of the parachute with all the suspension lines, and the second will be about 6 inches from the lower brake, because we have it's a blind bolt for on top of the motor casing, so just to prevent the twisting of the parachute, unthreading or taking the bolt out.
Okay.
Yep.
Nico, would you like to knock out the drogue?
Sure. Yeah, I can cover. Can everybody hear me okay?
Yep.
Okay, great. So yeah, for the drogue this year, we went with a redesign. We're going with I have a scale model here just to show you guys. We're going with a 30-degree conical ring slot parachute coming in at just under 5 feet in diameter. We're taking this approach to hopefully improve stability and reduce shock load. This year, we're expecting to, with a safety factor of 1.5, we have 3.6 kilonewton shock load. Without that safety factor, it's at around 2.4. And so we're finishing up the scale model now, and we're on the way to have that full scale fully implemented with the deployment rigging.
Okay, and so are you using a deployment bag or a blanket to disregard? You're using the CO2 ejection, aren't you?
Yeah.
Okay.
Yeah. Our expected descent rate with the drogue this year is at around 35 to 40 meters per second, which falls into the required range. If there's any other questions, please let me know.
Are you making that chute yourself?
Yes, we are. So this scale model was made ourselves. We ironed out all the manufacturing process just because it's a little more complex. We wanted to iron out all the kinks.
Yeah.
So we started production on our full scale, and so far it's on schedule, which is good news. And we're planning some final confirmation testing for performance and tensile strength for the stitches that we're using, but it's all looking good so far.
Good.
Okay. No, very good.
I'd just like to address something quickly, Bill. I'm not sure if it's on your radar, but we were told to make some last minute changes to Spaceport last year. We on our bulkheads where eye bolts are, it's a through hole, and then we use lock nuts on the backside. Last year we had blind with threads with Loctite, and our safety reviewers at the table wanted an extra swivel link for that purpose. So this year we lock nut everything in on the backsides.
Yeah, no, it's becoming one of the things that we noticed in the past is the potential for the, if you don't have a swivel link there, then to unwind that lock nut, and then that would not be good. Okay. Okay.
So for the recovery electronics, we have 2 redundant Easy Mini altimeters that are mounted on these boards. And each of them has its 2 igniters from the Apogee terminals and the mains connected to the Raptor CO2 ejectors in a fully redundant configuration. And they are both powered by the manufacturer supplied 400 milliamp hour lithium ion batteries.
Okay.
Yeah. And these are mounted.
And have you had a chance to do ejection testing on your system yet, or?
So once the tubes are finished, we do plan on doing ejection testing. We can't right now.
Yeah.
Okay. Yeah.
And the boards itself are secured to the bulkheads. So these holes, they're installed. So they're essentially wedges, and they're installed on the bulkheads. And then we're gonna have a cover over them. So in the event anything loose wire dangling, they don't damage the boards and electronics. But both of the deployment boards are going to be secured to bulkhead, while the rest of the avionics are going to be in a nose cone, which is why it's fiberglass and radio transparent.
Okay.
Cool.
Yeah.
Or bulkhead.
Yeah. Okay, so forward bulkhead's pretty much the same deal. We're using 2 Raptors again, with dual charge cups. So we put two E-matches in each Raptor. The way it's stacked is payload first, then on top of payload we have main and its bag, and attached to the bag is a pilot chute. Pull the bag out. As you can see, well, this is like the first run of a bag, but we're basically putting the payload in a bag and attaching it to the main riser so that when main deploys, the payload is pulled out as well. Since the payload has its own parachute, we chose to do a bag so that the parachute wouldn't get tangled in anything else. And the idea is that at a certain point, the flap of the bag will be released, and the payload, or in this case, 3 printed payload will fall out. The flap itself is controlled by, well, payload and a little Piranha line cutter, which sits in this housing, to A, attach it to the bag, and B, keep any incidents or exhaust gases from damaging either the payload or the bag. But since the Piranhas are so small, in our experience, we haven't had many issues with them. Yeah, the bag is basically, the flap is going to be held shut by grommets. They won't be on the side, they'll be more centered, and then they'll run across through the flap so that the line keeping the bag shut goes in tension just directly across instead of being pulled down because it tends to get stuck in the piranha, but we're gonna be doing more testing with that once the final iteration of the bag has been completed. And once we actually have a payload, or at least a section of the payload to trigger it to make sure that the system actually functions as it's expected to. So yeah, in this scenario, there's about 3 cases of things that we've determined can happen. One, the payload actually gets stuck in the body tube. In this case, there's so much shock cord above it that if the payload does get stuck, I don't see this being an issue for the recovery system as a whole and for the main. The second thing is if the piranha goes off early for some reason and it just goes off in the body tube. Again, I don't see this being a big issue. Odds are the payload will stay in the body tube. If it comes out on its own, well, it won't be in the bag anymore. So ideally the parachute would deploy and it would be on its way as normal. Like I said before, the piranhas are so small that I don't see this being a fire hazard at all. And we basically seal up the ends so that there's no flames or exhaust or anything like that coming out. So I don't see it being a huge issue. The third thing is if the payload comes out but doesn't release from the bag, so it basically stays on the line. From a deployment point of view, no problem here. There's enough clearance between all of the lines, so between the line attaching the payload and the rest of the rocket and the nose cone that will also be attached to the main line, that they can't interact with each other, they can't interact with the rocket or with the main and the suspension lines. So there's no risk of tangling there. There has been a discussion about if the payload gets deployed, will it get stuck in the main? And to be honest, I A, don't see this being a huge likelihood, and B, there's no way of us knowing whether that will happen, and I don't see any way of preventing that from happening. So yeah. On this line, it will be all quick links connecting the payload riser and nose cone riser to the main, except for at the top for the parachute to spin independently, we'll have one swivel link. And we are reflying last year's main. And Nico might be more familiar with the specs than I am.
Yeah, so I can cover that just really quickly. So yeah, we're using last year's main. It's test proven. So we've looked at it. It looks to be flight ready, apart from some suspension line retouch ups for the stitching, just to prevent unwanted wear. So we're just going to refurbish those, give it a good clean, and do a final inspection before reinstalling it. We're expecting around a 5 meter per second descent with the main. So it should still work with this rocket fairly nicely. And the colors so happen to be nice. Hopefully they're quite contrasting with the sky, so we'll be able to see both the main and the red drogue coming out, which hopefully will be a nice sight to see at comp.
How big is the main? What's the diameter?
Diameter is around 14.6 feet.
All right.
Yes, it's a chunky one for sure.
And shock cord?
Yep. I mean for the shock cord for the main, we're using the same 1-inch tubular nylon. It's purple. The suspension lines, I don't remember what we actually made it of, but yeah, that's what we're using for this year's shock cord.
To jump in, the tubular nylon is 13 kilonewtons in shock loading that's meant for its rock climbing backup, and then it's paracord that we use as our suspension lines, and those have upwards of it's like 600 pounds per line. We have 14 of them that split the shock load or something, so they're well sized. We did that last year.
Okay. Okay.
I guess
Looking.
Another thing I documented for the bulkheads. So eyebolts are all 3/8 inch, and then they all slot in here. So the bulkheads this year, they're all machine aluminum 6061 T6. They're designed with shock loading of the main and drogues in mind. So they've been topology optimized to handle that with a safety factor, I believe, of 3.5. Yeah, that's something I forgot to mention. They're screwed in with M5s onto the actual attachment rings, and all of the loading would be in both cases. So the front would be sort of in compression this way, and then the rear would put the bolts in tension. But yep. Okay, want to talk about payload?
Sure. So the payload is deployed. It has both Carleton SRAD line cutter and tracking. So it has a easy mini altimeter that will deal with deployment, as well as this board that will also send a signal to the line cutter. We have a biological experiment in the lower part of it. That is of the lowest biosafety level that there is, so it's not much of a
Right, using a like a cell culture, right? Is that what
Yeah.
your biological experiment is? Okay.
Yeah, it's to see the fluorescence of the cells while under the high G's of the rocket.
Okay. And you don't anticipate any problems with storage or having it out in the heat or anything like that while it's waiting to launch?
We have a fridge over there in the corner that's able to keep it at a nice and cool -7 degrees.
Yeah.
Okay.
Also going to insulate the compartment of the payload that has the cells in it, so hopefully they'll keep cool enough. If they don't, then rip cells, but oh well.
I can speak to this as well. I'm aware that they've been placed in an oven and cooked at similar temperatures to what would be inside the body tubes at Spaceport, and they survived long enough for a flight.
Okay.
So assuming normal procedures, we shouldn't run into too many issues, is my understanding at the moment.
Okay. Yeah. I mean, yeah, realizing that Murphy is always ready to pounce. But it sounds like you got a good plan at least. So okay. All right. And so you're putting the payload out at the main deployment. So you'll have and then it's got its own parachute. What kind of descent rate are you anticipating with that?
Sorry, what did you say? Descent rate?
What kind of descent rate on your payload?
I believe the predicted is 15 feet per second. Yeah.
Okay, so that's going to 15 feet per second. Okay, good. Okay, I was thinking meters, and I'm like, oh, that's pretty fast. Yeah. And what did you use to print the shell with? What kind of fiber? What kind of material?
So the actual housing of the aluminum, the test one is just a 3D printed piece but the actual one is made of an aluminum stringers and aluminum plate to reinforce it on sections. The microscope. Microscope. Oh yeah. Here's the microscope. It's machined aluminum.
Oh yeah.
But yeah, pretty neat.
Yeah, yeah. So the stringers and their aluminum pieces are going to carry all the load. Then so the cover is just the cover. Yeah.
Yeah.
Okay. Okay. And it's got its own. Does it have its own GPS in it,
Yep.
or?
It has a
Okay.
featherweight COTS and it also has a SRAD.
Okay.
GPS.
Okay. And for the batteries for that, what are you using there?
We're using a 4-pack of 18650s.
Okay.
We're using 2 of these. One is for the upper section of the payload that deals with the guidance and with the parachute, and one for the lower section that deals with the experiment and the COTS devices.
Okay.
avionics. Yeah. It's just one quick thing, I don't know. I mentioned it. The SRAD fiberglass nose cone. The reason we chose the fiberglass is because we split the avionics in two, so all the deployment stuff goes in the main body tube, and everything else goes in the nose cone, so it needs to be radio transparent. The installation is this plate that adapts to the stack that Mateo will show in a second, with the eye bolt also attached there. This will be shoved in here and then sandwiched in by the coupler. Mateo, do you want to talk about the stack?
Yeah, sure. Great. So this is the avionics main stack that's going to be in the nose cone. It's made out of bent aluminum and then 3D printed rails to hold all the printed circuit boards in place. The filament that we chose was ASA because it's highly heat resistant. And then we have this threaded rod here that secures all the boards in place and lets us kind of take them out easily. So the boards that we have in the avionics stack, we have a MCU and power board, which is going to mount a Raspberry Pi 4, which is responsible for controlling the telemetry system and also providing regulated 5-volt and 3.3-volt power to some of the other boards. Sensor board with a bunch of different sensors. We've got an IMU, a pressure sensor, a GPS, and a pressure and humidity sensor, humidity and temperature sensor. We have a radio board, which is this one here, using a long-range radio module that's going to be broadcasting our telemetry data on the 433 megahertz frequency band. And then we also have a COTS GPS board that's mounted in the same stack, but is not connected to the rest of the SRAD avionics. So it has a separate power supply and is not connected.
Okay.
I guess
All right.
about all of the arming solution this year is going to be done by pull tabs instead of key switches. Our previous vehicles has all been key switches, and the slight hump in the body that we had previously, that's pretty big detriment. And also with how thin the tubes we are this year, we're not confident that 3/4 of an inch hole isn't a well, it will be a place for stress concentration. So we're doing pull tabs instead, and I believe they are M3 sized tabs. Yeah.
So when you say pull tabs, you're talking about a pin you're going to pull out or something?
Yeah,
or
yeah.
what?
It's pull to arm. We have the design for them, and we have a few prototypes, but they're rolling right now. I can show you the CAD. It's attached on a report.
Or which one?
Pull tabs. Yeah. Essentially, I believe you can buy them COTS as well, but the ones you buy COTS are also just 3D printed. So we've essentially just reverse engineered and made our own version. That's, I think, what, $1 a pop.
Yeah, right. Yeah. So you're using the same Omron switches that
Yes.
LabRat uses, or something functionally the same.
Yep.
Okay.
And I believe
that works.
Every single system that's connected to a battery will have a arming switch. So one on the bulkhead segment for the deployment stack, 2 on the payload, and then 1 on the nose cone section. Yeah, and those will just be drilled to the same spec as our when we're doing the shear pins on it.
Okay. Yeah, and so so that was going to be one of my questions. You're using shear pins, nylon shear pins for your 2 brakes.
2 nylons, right?
Yeah. Probably 3. But we'll actually determine how many when we end up doing projection testing.
Okay. Fair enough. Yeah. You don't have to show me the
You have to.
I know what a nylon shear pin looks like.
Yeah. Yeah, and I guess we wanted to talk about the radio stuff. Kind of joke about Canadian units. Everything will be metric except for the mounting solution for these rings. These are 6/32, so number 32 screw. Is that what it is? Sorry, I'm not great with our metrics. Yeah, okay. Not great with my imperial fasteners. The only reason we chose this because we can get the 100-degree camera sync that you usually can't with metric fasteners. So we don't have to worry about knife edging the body tubes.
Okay. All right. So on your fin can, have you done your fin flutter calculations for that?
Yeah, so I've used that. Let's grab that. I believe our flutter velocity converted to imperial is 3,700 feet per second, which is around 1.8 times our maximum velocity. I'll just pull it up. Yeah, so the NACA technical report from the 60s.
Yeah.
Of course, like for system, like I think I made a comment on the report as well, is that because of the carbon fiber layout, the inherent nature of it, we're assuming a constant shear modulus, which we obtained from SSACP. There's a degree of assumptions and inaccuracies there, but regardless,
Sure.
it's a very conservative estimate.
Yeah. So it's liable to be, like I said, the error with the carbon fiber, the way you've got it, is liable to be on the good side, giving you more margin versus the other way around.
What's the maximum speed you expect?
Mach 1.86 at around 4,000 feet AGL.
Okay.
I believe so. I checked last there. I think so. Yeah. Yeah. The N5800 is a bit beefy. That thing is accelerating at 21.5 Gs off the rail, so we don't really have to worry about off the rail velocity as much. The thing will be going. Yeah.
Yeah, you should be doing well above the minimums there for that motor.
Yeah.
Okay. Okay. John, do you got any questions or comments you want to ask the team there, sir?
Not right at the moment. We've covered just about everything I can think of. I'm sure something will pop into my head.
Right. Okay. So how many for the team, how many of you have been to the Spaceport competition before?
I don't know the exact number, but a rough estimate would place half the team that's going this year. We have gone before. A few more on the team has gone to a different competition, the Canadian competition, Launch Canada. But for Spaceport, I think around half the team this year.
How many people are going?
Pardon me?
How many people you think are going in your team?
Currently, we have a lot. I think currently like 26.
The most recent number is 26.
Yeah. So are you gonna drive it all the way? Are you gonna fly down, or how are you gonna get there?
We have around 6 people that are taking a truck and trailer and driving down. We'll be departing the Wednesday before, so we get there by the Saturday and are ready, and the rest of the team are gonna fly in on Saturday.
Are you guys taking McMaster?
No. Do they need somebody? Because we're gonna stop past Toronto, so we can pick their stuff up.
I thought they told me that they were going down with Carleton.
Okay, then I'll you know what? I'll talk to them because that's perfectly okay. We're currently going with Western right now, as we're.
Oh, maybe it was Western. Maybe it was Western. Yeah, it was Western.
All right. Okay. We have a group chat with all the Canadian universities, so we can. We'll sort that out. Yeah.
Okay.
Okay.
Yeah, and we've got all the Airbnbs and rental cars and all of that.
Okay.
Planned out.
Good.
Yeah.
And where are you planning on staying? Are you staying in Las Cruces?
Yeah, Las Cruces, and all of our Airbnbs are like within like 5-minute drive from each other. It's I believe a 10-minute drive from the convention center. So we're just off that highway that goes over the mountain, if that makes sense. We're just like off that interchange. Yeah.
No, I think most of the Ezra Airbnbs are up there just north of US 72, because there's just tremendous amount of houses have been built there. And so
Yeah.
a lot of them, people have made them into Airbnbs for folks. So it's actually a pretty nice area if you haven't been up there before.
Yeah, and it's also the most economical for the team. Yeah.
Right. Yeah.
Yeah.
Okay. So just as far as the logistics, then so you've got your motor already, so that's good, and you bring in all the stuff on your own vehicles. Just one of the things that's changed this year, Ezra is going to be, or the Spaceport's going to be providing the shelter tents for your team area plus tables. So all you're going to be on the hook for is bringing chairs. So make sure you bring or buy enough folding, lawn chairs. I don't have to tell you, it's going to be darned hot. Harrison, you got a question, sir?
Yeah, I just had a quick question. I recall in previous years, sometimes there was like the larger team size spaces and the narrower or like the smaller ones. Is that still a thing, or are they all uniform size now?
I believe they're all going to be uniform, and I think, as far as I know, they're all going to be uniform, and of course, and we know you're one of the larger teams, so if it wasn't, I'm pretty sure they would have a double-sized space laid in for you.
Wonderful. Okay, thanks.
Okay.
I guess just one thing I have questions on. So I remember in 2022, the motor was assembled at the launch site of the VLA. But last year, the motor was assembled, or I guess for those who bought their motors from Animal Motorworks, it was assembled in some trailer park in Las Cruces, and the teams were then responsible for basically driving their loaded motor out to the site. Do you know if there's any changes this year that it will return to being assembled at the vertical launch area? Because I'll be completely honest, having a loaded motor in the car isn't the best thing.
Oh, heck yeah. No.
Yeah.
As far as I know, they're planning on having all the motors being delivered and assembled out at the VLA. Because we didn't have an issue. We had a rumor of an issue that somebody had brought a loaded motor casing into the convention center, which caused all sorts of consternation among pretty much everybody involved, which we think actually was just a rumor. Somebody said that somebody else said that somebody else, said that Team X had a loaded motor, but as far as I can tell, it wasn't really true. But because of that, I know they really, looked really hard at making sure that there's no or as little possibility as possible of having a repeat of that. So I'm pretty sure they're going to everything's going to be delivered out at the VLA.
Okay, perfect. That's good to hear. Thank you.
Yeah. No, it's that was a big point of contention in the in our review last year. We've actually ended up moving a couple of the pads just to increase our safety margins, and then also we've got actually now a formal launch matrix depending on the angle of where the wind's coming from. We've got new pads that are actually movable, so we can rapidly change the azimuth. And so we've got it figured out, if the wind's coming from X direction, we're gonna put the angle of the pads at this azimuth and so forth. And so there's Dr. Ken Overton has really put a lot of effort into, making sure that we have as little chance as possible of something coming down in the wrong spot. So that's going to be, there's going to be some change procedures, but that's mostly on the launch control operations side for that. Okay, so for those of you who've been out there, I don't have to remind you, it's going to be brutally hot. I think they're saying that we're even going to be above average for the spring and summer. And right now it's 100 degrees Fahrenheit, so you know, and we're still in May, so that's pretty strong. But you just remember, you know, dress appropriately, accordingly. You know, if you see me when you see me out there, I'm going to be wearing a big, you know, floppy hat. I'm going to be wearing a long sleeve fishing shirt, lightweight shirt, to keep the sun off my skin. Long pants, good shoes, everything. You know, it's not particularly dangerous, but there are, you know, dangerous snakes, and pretty much any insect you see will sting you. As well as every plant out there has something sharp to poke you with. So you know, so just, you know, it's not, like I said, it's not, you know, dangerous, but it's, you know, you just got to pay attention to that, and you know, so that you're not one of those who ends up in the medical tent because you accidentally backed into a crown of thorns choya or something like that, which you do not want to do. So
I guess.
go for it. Go.
So you were mentioning the heat. It's just a quick question. Last 2 years, I remember the launch queue. Like once we get cleared to go to the pad, that launch queue could sometimes last an hour and a half. Is there anything done differently this year to sort of reduce that, or because you mentioned that you guys reworked how the pads are. So I'm wondering that because we do talk about our payload being insulated. And if we have a better estimate of what the launch queue wait time would be this year, that may give us some better pointers on setting up procedures.
Yeah, it should be shorter because part of the reason we move the pads around is so that we can deconflict launch queues, so that we can actually like send people out to the solids pads while they're launching on the hybrid pads and so forth. So that should give a lot more flexibility and should get people out there in a more timely manner. I can't say it's going to be hugely shorter just because we've got, you know, now I think we've got 24 solid pads out there. So that's you know, that could be a fairly big salvo depending on, you know, how long it takes, but that's, you know, we've been aware of the problem. We're trying to make sure that we don't keep people out there any longer than they have to.
Yeah, fair enough. Thank you.
Yeah. Okay. Steam.
Has everybody got their EEE?
Yep.
membership?
Oh,
That
yeah,
was
that was going to be one of my questions here. Thanks.
Yeah.
Okay. And for those of you who have not voted, I encourage you to vote for the AAA directors elections. So I just voted myself, so I'll take care of that. Just you know, kind of the reminder is please do not paint or epoxy on your rocket while you're in your Airbnb. We, you know, have we had a problem not so much last year, but the year before, where a team pretty well trashed their hotel room doing that, and ended up paying a pretty hefty chunk of money to the hotel so that they could essentially refurbish the room after they got done with it. And you know, we had to do some sweet talking with the hotel operators to say, okay, you know, because otherwise they were saying, well, okay, we're not gonna do business with you. And so we, you know, kind of got them calmed down, but you know, just putting out the word to make sure, don't plan on doing painting in your room, please. Okay. So do you have any more questions for me?
I personally do. Harrison, do you have any?
Not that on top of my mind, no.
Yeah. No. Okay.
Okay.
Done for us.
Yeah. John, you got anything you want to add?
Not really. No. You guys had scheduled a review with us June 3rd.
Yes, June 3rd at 4 p.m. if I recall.
Yeah. Is that still on?
We're okay with that.
Well, not with me anyway.
No, not with you. Just with the
Oh.
flyer of record.
Yeah.
Oh, with the flyer record. Oh,
Yeah.
yeah, I gotta check on that for you, John, because that's, it's not something that I'm involved in.
No, it's just
Put it
with,
that way.
with me and the team.
Yeah, I don't, yeah, let me recheck for you, John, and
No, it's
actually,
just between, it doesn't involve you or Ezra or
yeah.
at all. Just,
It's
okay.
it's the Canadian Flyer Records and us.
Oh, okay, yeah, so that's, okay,
So that's
sorry.
still
I
on,
thought
is
you
it?
were asking me, yeah.
Yeah, so just to double check, June 3rd, right? I believe it was June 3rd at 4 p.m. Yeah.
Yeah, 2 p.m. our time.
Yeah.
Okay. Good.
Okay, perfect. All right. So well, you got look good. I think, it's too bad you didn't have, yes, sir.
I do have one, sorry to cut you off there. I do have one question. Or
Okay.
maybe one comment. We left it in a form at some point. I'm curious, who's doing logistics for recovery? Is it the same group as last year?
You mean, as far as Da Vinci with the, that, yes, it's the same group.
Will they have, has recovery been zoned in any way? Like last year's kind of separated by pads, but if the pads are moving, how will they track where recovery members are? Or will we expect change procedures from last year's recovery? Or is that something that Da Vinci handles completely separate of you guys?
Yeah, they're doing it separately. I know we've kind of streamlined some of their procedures based on, last year I think was way too clunky as far as getting things done, and I think they learned some lessons there, so that you can expect at least some modest changes to that, and to kind of cut down the bureaucratic stuff, if you
Okay.
will. Yeah, and actually, I'm the one who's going to be handling the post-flight data collection.
Okay.
So that will, and so I'm, going to be doing my best to really streamline that process. We've made some changes in our workflow. That's going to, I think that's going to make it a lot quicker and make sure that we collect the data properly. I mean, that's pretty much going to be my whole life is making sure we get the right data and get it in a timely manner so that so that we don't have any hiccups as far as the final scoring or anything.
Yeah. Right, well, that's all for me then. I can't think of anything else.
Okay.
Thank you.
All right. Well, if you would just drop me a note when you get your new fiberglass piece, just so that I know where you're that you've actually got it, and it's you're not still hanging fire in 3 weeks. Yeah.
I guess one thing I didn't mention. So we are the company that the vendor that makes these. We are in talks. They should ship a new carbon fiber tube by the 24th. If not, we have a contingency. We have a bunch of fiberglass tubes that are of the same dimension. It's just we will incur a 1.5 kilo weight penalty, and it's towards the aft, so we want to avoid that as much as possible. But yeah, we'll keep you updated on that. Yep, I'll just shoot you an email when we get a new one. Yep.
Okay, sounds good. Yeah, just one of the reasons we started doing this is that in the past we had teams arrive with basically a box full of parts and then trying to pull it together the weekend before the competition. So we want to make sure that teams are as ready as possible, as far enough advance so that we don't have repeats of things where teams are doing all sorts of doing tip to tip layups at the last minute to try to get a good rocket. So that's one of the reasons. But even but given the issues you've had, I think you've got a good plan to to recover and to pull together. And so I don't have any particular concerns as for, y'all have got a great track record. So I think it looking good from my perspective.
Thank you very much.
Okay. All right. Any last words, anybody? All right. Well, you have a good evening, good rest of the evening, good, last few hours of the weekend. And I look
See you in
forward to seeing
Mexico.
y'all in New Mexico. Yep.
Yeah.
All right. Thank you very much.
Okay. Take care.
Bye.
Bye.
Have a good one.
Bye.
Stop the recording.